right, welcome everybody. Good morning, good afternoon, good evening. Welcome to the Artificial Intelligence for Social Good Accelerating Learning session. Information exchange today is top of mind. This is co-hosted by the Qatar Computing Research Institute, the UNDP Accelerator Labs Network, and UNDP Innovation in the Arab States. That's where I come in. My name is Jennifer Colville. I am the team lead for innovation in the Arab States, based in our regional hub in Jordan. Really happy to be working with QCRI and the Accelerator Labs team on this. Today is the first of a two-part series of exchanges. Today, obviously online for the most part, we will be exchanging experiences and expertise in using new types and sources of data to address development challenges. And it's also an opportunity for us to find areas of collaboration between our friends at QCRI and the UNDP Accelerator Lab teams. The second part will be an in-person event that will take place, hopefully, in June, mid-June, in Doha, Qatar, with QCRI, where we bring colleagues from around the UNDP system working on data central to collaborate with data scientists at QCRI, plus from the private sector, from public sector, from academia, variety of sectors to come together to address development challenges through a data lens. So let me take us through quickly what we'll be doing today. So we'll have some opening words from our co-hosts at QCRI, as well as the Accelerator Labs. And then we will have a short presentation on UNDP's data strategy from the digital office, UNDP's digital office. And then we will get into a fast and curious set of presentations between the Accelerator Labs and QCRI researchers. We've split this up and arranged it according to 3 thematic topics. The first will be on migration, mobility, and employment. So we'll have a series of UNDP presentations and then a series of QCRI presentations. Same for the second topic, social media, misinformation, and gender. And then the third topic is around remote sensing and environmental conditions. So you see, we've got 20 presentations coming up. It is going to be fast, 2 or 2.5 minutes per presentation. So really just meant as a teaser. So we'll do our best to keep to that schedule. And then we'll conclude the public portion of the session this afternoon, and then we'll take a short break, and then there'll be an opportunity for dedicated channels for UNDP Accelerator Lab presenters and QCI researchers to meet by thematic to go into more detail on their work. So that's kind of how we're going to play it today. I think maybe just a couple of housekeeping notes. We are recording the session and we'll make this publicly available. We will have short time for questions after the presentation of UNDP's data strategy, but unfortunately not time for questions after each of the presentations. So if you do have questions, we encourage you to put them in the chat, and we will do our best to respond to them real time or after the session today. If you have any work or things that you'd like to provide a link to, we ask you to drop them in the chat as well. If you have an interest in joining us for the second part of this two-part two-part exchange that will happen in mid-June in Doha. Please be in touch with any of us, any of the co-hosts. We will put up the email addresses in the chat box, but also at the end of the presentation. So please be in touch with us. Definitely, the more the merrier in terms of addressing these kinds of challenges. So I think that's it. What I would like to do is go straight to our co-host, Dr. Richard O'Kennedy, Vice President of Research at Hamad bin Khalifa University, as well as Vice President of Research, Development, and Innovation at Qatar Foundation. With that, Dr. O'Kennedy, over to you.
Well, thank you very much indeed, Jennifer, for that very nice introduction and for highlighting this.
Oh, you're muted.
So good afternoon, everyone, or good evening again. Can I just thank Jennifer for that excellent introduction and for highlighting the event and the activities that are going to take place. I'm delighted to welcome all of you. Some of you I've met during the meeting in 2019, and I think this is a very, very important area, both for the UNDP, but also for Qatar Computing Research Institute. We highlight and want to develop these types of activities that are, trans-global and very much associated with Qatar. Currently, the Doha Forum is going on here in Qatar, and many of you may have seen on the global scene how that it's picked up a lot of very interesting interactions because it's geared towards bringing people together, discussing problems and highlighting ways forward. And when I see your meeting here today and the meeting that's projected to occur in June, and we'll be delighted to see you all here and to welcome you physically in the next meeting, because COVID, of course, has had a huge effect on us all for the last while. And I think it's really in bringing people together. In fact, there's an extra excitement on it. So I want to say that I'm delighted to see this meeting going ahead. I can see from the agenda you have a lot to do. QCRI has been very much involved in building global activities, and I know the UN has also been doing that, and through your Accelerator Lab and through these programs, I think it's very, very apt to have these meetings and to work together. I know you have a lot to cover, so I'm not going to take too much more time. As I say, really enjoy this event, build great collaborations. I'm a scientist, and I know that really when these come from the ground roots, they develop in a much more comprehensive way. And I wish you the very best for your meeting. And as I say, look forward to meeting you in person when you come here in June. So the very best wishes to all of you. And thank you for the opportunity to introduce and welcome you. Thank you, Jennifer.
Many thanks, Dr. O'Kennedy. Really appreciate it. Appreciate the collaboration, long-standing partnership with QCRI. We're quite happy to continue that and deepen that. So with that, let me introduce Gina Lucarelli. Many of you know Gina, if not everybody knows Gina, it feels like. Gina is the team leader for UNDP's Accelerator Lab network, leading the ship on this great initiative and bringing together so many accelerator labs today. Gina, over to you.
Thanks so much, Jennifer. And thank you, Dr. O'Kennedy. And thanks so much to all our colleagues at the Qatar Computing Research Institute for making this happen, Ingmar and many others. We're really, really thrilled to see this work happening. For us at the UNDP Accelerator Labs, what we're trying to do is help create actionable insight to accelerate progress on the Sustainable Development Goals. We know we've only got now less than 8.5 years left. And it's really time to accelerate. We also know that there still exist a lot of data gaps when it comes to knowing certain things about the state of sustainable development. We don't even know our starting point, so it will be very hard to assess progress as we go forward. But most of all, this work for me is advancing the work that we're doing on understanding how you tap into collective intelligence for sustainable development. Here we're talking about artificial intelligence. Our primary focus is mobilizing people to work together, often with the use of machines and often by tapping into new sources of data, unstructured data, in order to mobilize a wider range of insights, ideas, and solutions to make sustainable development breakthroughs. So you will have known that last year we started some work that's available at smartertogether.earth. This was our first research into collective intelligence for sustainable development. Here we're looking at how do we tap into the knowledge, perceptions, and actions of almost 8 billion people around the world, because we know that collective intelligence is a decentralized problem. It's a fast-moving dynamic, and we need to know at a quicker rate what's happening so that we can inform decision makers with better data to make better decisions. So I would thank you, Ingmar, for putting that in the chat. Do check it out. One of the things we found in that research, we looked at over 200 organizations, and we looked deeply at UNDP's own work. We saw that while collective intelligence is mostly about humans, the work when it comes to tapping into new data sources needs to accelerate. There's so much promise here, and there really is a question as to what do we need to do to take this to scale. So I'm really looking forward to this event and the proof of concepts that you all will be working on, the advisory support from QCRI, the action on the ground from the UNDP Accelerator Labs. Thank you so much, Jennifer and the team at the UNDP Arab States Innovation Team for making this happen. Looking forward to following this today. Thanks so much.
Great, thank you, Gina. All right, with no further ado, I'd like to introduce Gayan Perez, who is our strategic specialist in our digital office, UNDP's Chief Digital Office. He will give us a keynote presentation today on UNDP's data strategy. So a newly defined and launched data strategy that kind of underscores the importance that we as an organization place on data for development. So with that, Gayan, I will hand over to you for our presentation. Thank you.
Thank you very much, Jennifer. Good morning, good afternoon, good evening, everyone. So my name is Gayan Perez. I work for the Chief Digital Office of UNDP, and I co-lead the implementation of data strategy in UNDP. Next slide, please, Jeremy. So today I'll talk a bit about UNDP's data strategy, but I'll talk a lot about how it enables data innovations at the field level as well, some of the initiatives that we already have in flight. Next slide, please. So what's the journey for our UNDP's data strategy now? First of all, back in April 2020, UN Secretary General and the Executive Committee approved UN's data strategy, and it not only set data at the heart of UN, but it also gave us a blueprint for all the agencies to follow as well. So that is our starting point for the data strategy. And when we looked at UNDP, it was not like we were not doing anything on data because we didn't have a data strategy. We were doing a lot of initiatives, including our own human development report and the Human Development Index, but there were so many initiatives that happened in silos. When we did the interviews for the data strategy, we realized even in certain cases, two teams have purchased the same data set and they're not talking to each other. So this created, this challenge created an opportunity as well for have a long-term data strategy for UN, enterprise-wide data strategy for UNDP, with the goal being leveraging data as a strategic asset in UNDP and UNDP becoming a data-driven organization. And this is also underpinned by our recently released digital strategy as well. Data enabling UNDP is one of the pathways, and UNDP is, sorry about that, and UNDP wants to become a data-driven organization. Jeremy, next slide, please. Now, before going into data strategy, anything we do at strategy level, also the policies we create, the technology we create, the initiatives we create, change over time. They have to change over time with the new development landscape. But there are principles that we want to ground in UNDP. So even before the data strategy, we had these 8 principles approved in UNDP. I'm not going to read all of 8 of them, but I want to take your attention to first one and the fourth one. First one being privacy by design. We take data privacy very seriously in UNDP. And we want privacy not to be an afterthought. It has to be embedded in your design process. And the fourth one is making data open by default. Now, that's a big statement for an organization like us. Anything that you do on the field, not just the data that we collect through socioeconomic impact assessments that we are doing on the ground, and damage impact assessments we are doing, the Crisis Bureau is doing, not just that, but the machine learning models, the AI models. We are making a commitment here to make those open by default, keeping privacy at the core of everything that we do. Next slide, please, Jeremy. Now, UNDP's data strategy is on 3 key pillars, or we call them enablers for you: on governance, people, and technology. And we take partnerships as a cross-cutting enabler across these 3 pillars. I'll talk a bit about governance. First of all, it was very important for us to have some sort of a structure when it comes to making decisions about data. But UNDP being a large organization, we didn't want to take a very compliance-driven approach to governance. We took a value-driven approach. What that means is, no one is going, when you're doing your data project at local level, no one is going to come from HQ and say, hey, stop, don't do that. This is the way to do that. Instead, we are providing you with guide rail, what we call guide rails or guidance on where to start your project, how to go about your project. But if you have an exception for some reason, for some reason, you have to collect personal information and share it with another agency, then we have created a clear path in the organization, including a data governance group with very senior level representation to make those decisions for you as well. I'm going to talk a bit about guide rails in one of the upcoming slides, so I'll stop there with governance. And on the people side, now for the first time, 3 teams come together in UNDP to implement the data strategy: the Chief Digital Office, our Global Policy Network, the GPN, and also our technology team, ITM, comes together to implement this data strategy. We want the people component is mainly focusing on building existing capacity of UNDP, also bringing in new talent into UNDP as well when it comes to data. Now, on building capacity, we are making a lot of training courses available. There is a basic data training course which sets a baseline for UNDP. At the same time, we are making a lot of on-demand training courses available on machine learning, AI, and using non-traditional data. These are on demand, so we have to create a cohort of some sort before offering you those courses. The other side of things is bringing data talent into the teams. In fact, we encourage bringing data talent into the teams. What we have done is we've created templates for terms of reference from G5 to P5 level for data scientists, data managers, data analysts, data visualizers. They are available as well to the entire organization. And on the technology front, we are focusing on self-service architecture. What that means is, earlier the practice was, if you have a data project, you probably do it in your computer, or you purchase some cloud storage somewhere or cloud processing somewhere. Instead, we are offering that as a corporate offer from UNDP, and it's self-service, so you don't have to send a request to IT and wait till they approve or wait till they provide help. It's all drag and drop, which I will show in a minute as well. And we are taking partnerships as a cross-cutting pillar, so I'll talk a lot about partnerships when we come to the data innovations part. Next slide, please, Jeremy. Now, for any strategy to come to life, there should be some strategic use cases and things that bring the strategy to life. Otherwise, strategy remains at that very conceptual level. So the first data innovation is, next slide, please, Jeremy, is the Data Futures platform, as we call it. It's available at data.undp.org. And this is an effort to bring those previously siloed data initiatives under one umbrella. Through that, we are providing a single source of truth for data. When it comes to technology, everything is in one place. When it comes to governance, we are applying a little bit of governance process on this as well. How the story that you want to communicate is communicated as well. We are taking a lot of knowledge that our Human Development Report have acquired on communicating what you find. And there are some interesting analysis on the Data Futures platform. What you're seeing is the vaccine equity dashboard, which was on media recently as well. And there are some real interesting analysis there on temporary basic income, fossil fuel subsidies, and we have country level analysis as well. There is a page for every country, and we are trying to bring in that programmatic side. What sort of data do we have available in the country? Non-traditional data available in the country, the type of analysis we've done in that country, also UNDP's project and program offer on that country as well. So this is one of the first efforts to bring all of that. Next slide, please, Jen. And I wanted to show what's under the hood a little bit, because that entire platform, data.undp.org, Data Futures, runs on UNDP's corporate technology architecture. And this is available for all UNDP staff for free right now. And it's all drag and drop. What I wanted to show you is that entire pipeline for vaccine equity is all drag and drop here. It has capability to go and scrape data from a website. You can connect to about 300 different sources, including connecting to APIs as well. And you can do this. You don't need specific data knowledge or get a data scientist or get a data architect. It's all drag and drop to create this pipeline and mix data, and even go into machine learning. The entire stack runs on Microsoft Azure, but that doesn't mean it's all Microsoft. If you are feeling a bit geeky, you can write your own Python code or R code, or you can run things like open source applications like Databricks on top of it as well. So we've kept it very flexible. Next slide.
I think you are muted again.
Maybe the host muted me. Okay. So we put this under under innovations because this is one of the first in the UN system. What we are doing is those data principles and the data policies, we are bringing it closer to you through these guide rails, and it covers the entire data life cycle. So this sits between having policy and not having anything, giving guidelines for you on your data project. Next slide, please, Jeremy. So these data guide rails, if you can read the small text on the screen, actually dives into details like types of data, bias mitigation, the entire life cycle from data collection to data storage to data publishing. It's a 160-page document, but that itself is the problem. You're not going to read a 160-page document before any data project. So what we are going to do is break it down to smallest components possible and make it available as an AI chatbot in our service delivery platform, UNAll, where you can have an intelligent chat with the chatbot, give a bit of keywords, tell it a little bit about the project that you're doing, and it will guide you into the sections which are applicable for your project. And this gives guidelines on what are the base layers you have to use for maps. Is there a standard taxonomy for country list? All of this information is available. The frequently asked questions from UNDP on data is available under these guide rails. Next slide, please, Jeff. Another, I said we are focusing a lot on partnerships. In fact, this is one of the first partnership initiatives that we are focusing on, called Development Data Partnership, which was started by the World Bank, but now we are one of the co-members there as well. So what it does is creates partnerships with 22 right now and counting different private sector data providers. So what we are doing at the corporate level is having master data agreements, the MDLS, master data licensing agreements, with all these 22 different data providers. So the conversations become much more easier for you at the country level. Also, you have access to data. How it works is, if you have a project, you can send a proposal and mention the data sources that you want, or the data providers that you want data from. And the provider looks at the proposal and approves or dumps the data into a GitHub repository where you can use the data. And as you can imagine, having 22 different master data licensing agreements are a lot of legal work. So we are about 2 weeks away from signing most of these agreements, and soon this will be available as a service for UNDP as well. I just wanted to tease you with a bunch of initiatives that are already happening, which are not run by us because the agreements are still not in place with these providers. Next slide, please, Jeremy. I just took a screenshot, in fact, of some of the proposals that are submitted already. And as you can see, there are some interesting analysis that is happening already by the other development agencies that you saw there as well. What we are going to do is in the coming weeks, through these Data Thursday sessions we are having every Thursday in UNDP, we are going to bring these people who have done these initiatives and talk about those initiatives, so you can take some inspiration from what's happening as well. And as you can see, some of the data providers are Mapbox, Outlogic, Facebook. There are many, and I've seen some interesting analysis on green jobs created in past 2 years with data from LinkedIn as well. So there are a lot of interesting projects happening there. Hopefully soon, a lot of UNDP projects will be in this list as well. Next slide, please, Jim. And UNDP is also a part of Global Data Access Initiative. Now, this was started by UN Global Pulse and led by the Jakarta Pulse Lab. And this is an initiative with funding as well for taking a use case based approach for data access, which means they have already selected 2 UNDP projects with the Crisis Bureau on vulnerability mapping and damage impact assessments in Philippines. What they're doing is they want to get call detail record, the CDR records from the telecommunications companies, and they want to use non-traditional data. So once again, they are agreeing with the like creating these MOU templates and templates to get data is the key here. And also this is also part of the Digital Public Goods Alliance. So anything that happens within the Global Data Access Initiative will be contributed back to the Global Data Access, Digital Public Goods as well. So Global Data Access Initiative takes a very use case driven approach. Next slide, please. We also have a collaboration project with GIZ on data collaboration at local level. Now, what this does is creating a blueprint. Gina talked about data gaps at local level, taking 2 countries as pilot. And we are now in the process of selecting those 2 countries. And this is a project where Accelerator Labs input directly will be taken into consideration on which countries to select and the data gaps in the country office as well, and the work that you do at country level as well. We will create a blueprint on how to success at the local level with data innovation and contribute that blueprint, pilot that blueprint in 2 countries and contribute it as a digital public good as well. There will also be a course created on the ITU's website as well on this. So this is another partnership initiative we have running at UNDP. Next slide, please. Well, that's about it in terms of the data strategy and how it's coming to life with local data innovations as well. As you can see, we are putting a lot of emphasis on partnerships because we feel that is the only way to move forward. To quote our administrator, the future of development is digital, and data underpins that development, and no single data provider can do that task. We need to come together. So therefore, we're putting a lot of effort on partnerships, and there will be a data strategy refresh coming very soon as well. A lot of emphasis will be made on these partnerships, and for you to take away is we are making these MOUs, the legal agreements at the global level, so the conversations at local level for you becomes easier. Thank you very much, everyone. If there are any questions in the chat or you want to ask me any questions, I'm happy to take them.
Gayan, thank you so much. I work at UNDP and I didn't know all of that. It's great to hear and to know what we have coming down the river. So thank you for sharing that. So appreciate that. And Gayan, thank you for joining us today to share UNDP's data strategy. So with that, I'd like to hand over to Ingmar Weber from Qatar Computing Research Institute and Jeremy Boyd from UNDP Accelerator Labs Network, who are going to take us through this rapid style presentation, series of presentations as we go through the rest of the session today. Ingmar, Jeremy, over to you.
Sure, yeah, just quickly say a few words. So hello, Earthlings, also from my side. Welcome to this event. Yeah, we'll have a set of, very short presentations organized by three subject areas. And I think we'll always start with the team from sort of the Accelerator Labs, and then sort of our side will respond. So, and with that, I'll hand back to Jeremy, I think, to lead us through the Accelerator Labs first set of presentations.
Sure, thanks, Ingmar. Hi, everyone. Jeremy here from the Accelerator Lab global team. We don't have much time. We're already a bit late, so I'll just jump straight into it. We have 10 presentations, as Ingmar just reminded, broken down into 3 groups or 3 topic areas. The first one on migration, mobility, and employment. So we're going to listen to 2 presentations from Accelerator Labs and 3 presentations from QCRI researchers. And without further ado, the first one will be from Serbia. We'll hear from Draško. He has shared a video that I'll play now, and then he'll say a few words after the video. So I will play it here right now. Draško, over to you.
Yeah, thank you. Hello, everyone. I hope that you could see the video well, because it was lagging a bit on my side, but it's fine. This was our entry to UN World Data Forum last year. This was one of the initiatives by UNDP Accelerator Lab in Serbia, where we are trying to get some new insights about depopulation that is happening in Serbia. And we have a portfolio of data solutions that we developed in Serbia with various non-traditional data sources that we've been using. Among them, LinkedIn data, Google Trends data, mobile data through our partnership with all 3 Serbian mobile operators. Satellite data, we used some night lights analysis, Corinne land cover analysis. We used OpenStreetMaps analysis, job ads data through our partnership with the biggest local job ads portal. This Facebook audience estimates that you just seen. Then we used Microsoft academic data for academic diaspora, brain drain, and we also have some work in the area of machine learning and predictive analytics. We utilized the random forest algorithm to connect the indicators that we derived from diverse sources of data with population estimates across the municipalities in Serbia from the statistical office, so the official estimates. Basically, we tried to evaluate, to train a model and evaluate it for each of the 5 data sources that we used, and they were mobile activity, connectivity, mobility, Korean land use, and OpenStreetMaps. And we created a fused data set. We wanted to understand which indicators are the most useful in a model's prediction. For more info, I'm going to share the link to our local website, which includes all our analysis and the data set and the source code for you to read when you have time. Thank you.
Great. A special thanks to Josko because you're on leave right now, if I'm not mistaken. So thank you for doing it.
But
Thanks,
still, I'm very, very pleased to be here. Thank you.
Thank you. Cool. Moving on, in our fast-paced session here, we will go to Colombia and Juan David, who will talk about AI and human capital in the scope of the Venezuelan migrant crisis in Colombia. Over to you, Juan David.
Thank you, Jeremy. Good morning to everyone from Colombia. I'm going to try to make this fast. We were talking with Jeremy the amount of slides because the contents that we were going to show was broad and we thought really interesting. So this project has already 2 parts. The first part, a close collaboration with other labs in getting all the knowledge they had about migration with the country office, which we saw the opportunity. If you can help me with the next slide, Jeremy, please. The opportunity to work on a requirement from government in a new status for Venezuelan migrants, and was to give them an identification. So not only seeing the opportunity of the identification for migrants, we saw the opportunity to make this card socioeconomic inclusion project. So we began to work on identifying what could be included into the platform and designed an intelligent document that would have a RFID chip. Next slide, Jeremy, please. So the idea was to develop the card, an application, a platform, and a server where people were going to be able to upload their document and the data, and it would be triggered to the app. So if you were a government agency or, for example, a health agency, you are going to be able to see what kind of documents the migrants put into the server. Next slide, please. So we built the prototype, conscious that we were not using the proper UNDP, that the proposal made by the provider, but we made the Smart ID prototype. We made the Smart app. Put this next slide, please, and showed it to government. So at that point, when I was shown to government, we tried to make the whole procurement process to be able to give the card for the Venezuelan migrant, but due the time frames and the lack of the microchips and everything that the world had a crisis on that, we were not able to put the chip on the card. But we helped the Colombian government give 2 million identifications last year, and this year the whole program is being deployed, and help them with the whole procurement with a close partnership with Copenhagen. So this was a lot of collaborative work between the Colombia office, Copenhagen, and for this to happen. Next slide, please. So you can see here, this is the news, October 2021. The identifications were beginning to give them to the Venezuelan migrants. From the actionable insights and the learning that we've had and the close work with the Peace and Justice team, and especially with the Human Development team here in Colombia, we are making a new proposal on how we can work with a labor market and use the IDs. Next slide, please. So this is the vicious cycle of labor market where the supply and labor are not aligned. So what we're gonna we're going to make with the human development team is work. Next slide, please. Is make a characterization of the target population, identify what's happening by wet scrapping techniques, understand what is the demand, what is the offer, and also work, and this is really key for us, with social understanding. So what are the migrants also looking at, what are they saying in other platforms or social platforms? And from there, we are going to make the whole learning and understand what are the needs. So what we're going to do is apply the web scraping, the data mining and text mining, in able to make the machine learn and make the clustering in order that we match the vacancies with the skills. Next slide, please. This is an example of what's been already done by the human development team. So the Department of Education in Colombia needed to obtain information about the behavior of the labor market in the tourism sector. To provide information, the team designed a dashboard in which the results were shown. So this is like an initial prototype also of what's been done by the team. And we're matching together with the lab and that team to make the new proposal. And the last one. So what do we believe are the added value and achievements? That we're going to be able to increase the matching rate between labor supply and labor demand. We're going to be able to promote productivity within the private sector through the accommodation of workers with specific skills needed by the.
You're mute, Juan David.
Sorry. Okay, but not going further into that. These are like what we're trying to prove with this new prototype on using the migrant ID and working with migrants for socioeconomic inclusion. So that's a really short story of the work, what we've done, how we made these actionable insights and learning for a new iteration of the project for social economic inclusion. So that would be it. Thanks a lot.
Great, thank you, Juan David. Very hard indeed to compress all of this into such a short time. Over to you, Ingmar.
Great, thanks. Yeah, so let me share some slides at my end. So great. Yeah, so I'll actually present myself first, and what I present is a sort of intersection of what Juan David presented and what Draško presented, because I'll talk about Facebook data, but in the Venezuelan context, or in the Colombian host context. So just for people who maybe haven't seen this before, so this is a screenshot of Facebook's advertising platform. So this is publicly accessible. Again, I'll make this sort of very clear. So you have access to this data. If you go home, you just follow the steps of launching an advertising campaign on Facebook, right? And so here I'm targeting people who are living in Norte de Santander, which is in Colombia on the border with Venezuela. But I'm only targeting Facebook users who used to live in Venezuela. And then Facebook's advertising platform tells me how many people match these targeting criteria, right? So this is both what Draško was using, if I understand his presentation correctly, right? And so what can you do with this? So you can look at sort of relative trends. This is something that we did in the Venezuelan context, and see how this changes over time in different host countries and regions. You can look at trends across space, so also for countries that don't have this data available. And you can also look at socioeconomic differences, but if you look at whether people connect to Facebook using iOS or Android devices. For example, in Roraima, Brazil, there are hardly any iOS devices, whereas people who make it all the way to the United States actually are quite likely to have iOS devices. But in all of this work, you need some sort of modeling if you want to get to absolute estimates, because of course not everybody is on Facebook, and there are also some sort of false positives or sort of duplicate accounts. So this is sort of one line of work I quickly wanted to mention. Happy to discuss more later. We're doing something similarly in the context of Ukraine with the University of Oxford, but that's quite sensitive in terms of results, so I don't want to publicly present this right now. Another line of work we're doing looks at satellite images and looks at cars. Right? So here I'm showing images from Al-Bab in Syria, where you see, mid-2016 there were cars visible, and then late 2017 these cars are gone. So what happened, sort of, right? And so we have we sort of use computer vision to detect cars, in the whole city, right? And so if you have this sort of pipeline, you can run it across snapshots of time to look at sort of trends over time, right? Sort of our cars sort of disappearing. are, of course, sort of reappearing, right? Sort of, and so far we are sort of mostly looking at the locations of origin, but of course you could also look at the potential destinations to sort of to see if people are sort of moving from one location to the other. Now, this does not work in all places. You know, globally it assumes vehicle-based displacement. So in other parts of the world, you have caminantes, right? People working, you know, walking or sort of train-based displacement, and that would not be visible from space. But again, this is something, if this is of interest to you, come talk to me. And again, this is something we're also doing in the context of Ukraine. If that's of interest, come talk to me, and happy to share some things that I don't want to talk about publicly. Other stuff, so LinkedIn has also an advertising platform, so you can look at how many people studied in Serbia and now work in IT in Germany, for example. You can get Google Maps live traffic, and I don't mean driving traffic, but in-store traffic. So you can sort of look at whether a certain location is popular or not, and how that changes at the hourly level, very fine-grained. And you can also try to look at sort of use Google Trend data to predict migration. This is something we're doing in the European context. I'll stop there, and I'll hand over to my colleague Sanjay, who I believe is also on the call.
Hi. So yeah, thank you, Ingmar. So I'll talk about AI for SmartX, and since this is accelerated learning, I won't talk about an application, but I'll talk about how to do AI, and I'll stop whenever the time runs out. So how does AI work? So yeah, so let's start with an example of water body, which is, people are predicting that this is the future involuntary migration will be about water. So here you see a lake, and you see the boundary of a lake, and how do you identify whether it's a lake or land? So you take some pixels, and just imagine you have two spectrums. So the blue pixels are the water pixels, and the brown pixels are land pixels. And now you want to distinguish what is a land pixel, what is a water pixel. So what do? You draw, next slide, you draw a line across them. Anything on the left of the pixel will be a blue pixel. Anything on the right of the pixel will be a land pixel. Now, if you have a new pixel come in, you'll classify it as a land pixel. Next slide. But life is not that easy. Sometimes you have these pixels, like the brown pixels and the blue pixels are opposite each other. This time I would stop and ask you, is there a way to draw a straight line across them? And if you go through the next couple of slides, of course not, of course not. You can put an ellipse around it, but what if you want to put a straight line up through them? Is there a way out? Well, the solution is you have to go to high dimension. When you go to high dimension, you have, say now, instead of two features, two axes, you have three axes, and then you can separate the brown pixels from the blue pixels. And that basically how modern AI works. You separate data of pixels, land pixels, water pixels, road pixels, forest pixels by going to a high dimensional space. And this is done now automatically using deep learning. Earlier it was done using handcrafted features. But of course, you don't stop at 3 features, you go to 100 million features. But you have to pay a price. The price you have to pay is that the features are often uninterpretable. You have black box models. You need experts to figure out what is why this is happening. And that's where the big bottleneck in AI is currently, how explainability and interpretability. So next slide. So this is what we did recently. We've been working for a long time about map inference, how to automatically detect maps from satellite imagery. Here's an example of how to identify road attributes from satellite imagery. So here we have, roads, the network is given, and you want to identify whether the road has 2 lanes or 3 lanes. What we do is we take context into account. So we combine what are called deep networks of both convolutional neural networks and graph neural networks to get the context. As you can see, if you have an overlapping, one sort of road is overlapping the other road, we can still identify that it has the highway below the overlap has 4 lanes. If you have shadows, because of context, we can pull in the information that the number of lanes in the shadow will probably also be 2 lanes. And similarly, if you have occlusion, then we can do that too. So now we want to use this for, as I mentioned in the beginning, the water project. because we want to build a planet scale system where I can show you a lake, and and the system will tell us how much water there is in the lake. So yeah, so that's my accelerated learning class for today. Thank you.
Thanks. Do we have G?
Okay, so thank you. So today I'm going to talk about the jobs. So, we talk about the AI and machine learning, and we talk about the jobs. So here, our project is how can we AI, or how we know the job market or education. So we found that there's a trend, a lot of AI. So there's a technology innovation, but it's very far away. So we want to using some pattern data with some specific jobs, and we want to find that what kind of a task or what is the jobs augmentation score. Next one, please. So what we have done is if you go to Google's website, there's the pattern Google database. So basically they collect all the US patterns or all of the other countries' pattern, and then they put in the database. And then if you look at from ONET, it's a famous job bank, like a job database from US. It's about over 1,000 jobs are listed. Also in there, it's not just about the job, it's a task, also education and the qualification and what kind of software, and then what else they need to have at this job. So what we have done is that basically we get this ONET job description, and we got the pattern from the Google. At this point, we use just the English and the US patterns, and then we train basically neural network. And then after that, looking at each, looking at the embedding and some allegation, we are able to get in the job or in the task score, and that is indicate indirectly or directly is indicate the impacts in the job market. Next one, please. So we create one application based on that. You can see one of the sample. Basically, if you look at the left on top, actually this is accountants. It shows that it's AI augmentation score is about the 65% if you round about it. And then it has the description about this job. And this one is from the ONET database. If you can see this highlight, we call this is the attention of the word. So each word, how much of the is the indication for the AI for this job. So there's a little bit, some of them are very stronger, some of them are less. And then below on the table, you can see the task, and there is a responsibility. Also, we also highlight each word. This one is put a lot of attention for the AI and what it is score. Next one. And then could you open the site?
It's a bit difficult, so if it's okay, maybe we can just drop the link here in the interest of time, because I don't think it'll work very well. Sorry for that. So
yeah, once we train the patterns and the jobs, so we create a lot of some samples about the 1,000 jobs in the ONET database. For example, there's actor, accountants, or software, or some CEO, some position. It shows what will be their AI augmentation score, and then what skills that has be kind of augmented with the AI. In addition, actually, we show the relevant patterns. If you go there, if you click on the right and left side on top, there's the a US pattern. By click them, you can see what is the trend in this view, what kind of pattern there is, or it's about the top 5, so you can overview. That's it.
Great, thank you so much. So back to you, Jeremy.
Thank you, Ingmar. Sorry. So we're going to switch now to the second part, second group of presentations on social media, misinformation, and gender. Here we will have 4 UNDP Accelerator Lab presentations and 4 QCRI presentations. The first one will be from Najwa in Morocco on AI for fair digital finance. Najwa?
Hi, everyone. I'm really happy to be here. So what's AI for fair digital finance anyway? Just a little bit of context, Morocco has one of the lowest financial inclusion rates, especially for women. And since consumer protection is one of the pillars that's helped advance financial inclusion, we looked, along with other things we're developing as part of the same portfolio on SDG finance with the central bank, into how we can design evidence-based ways to shape up pro-consumers policies and regulations. And then a question came to mind: if AI can help detect poverty levels based on GIS data, what if we can help detect digital financial services fraud and other risks based on social media data as a good proxy? And then when we went on with an extra layer where we are on the lookout, not just for the risk facing consumers, but for the risk relevant to the ones who are the most vulnerable to those risks and who tend to live in low income settings. We're using social media data as a start, but we are planning to then create custom-made data in more advanced stages of developing the tool. The first data sets that were considered are social media, public pages, and hashtags, since these are the most popular among the 24 million social media users in Morocco. And then there is the nuance of finding people we intend to serve where they are. For instance, since we couldn't find their voice in Twitter, we didn't make it part of the data sources. In future stages, we're planning to feed in additional sources of data, such as data from the existing digital literacy chatbots we're developing, as well as designing a hotline kind of chatbot voicing customer complaint that will generate useful data for oversight and policy formulation. Our lab's AI tool for fair digital finance is designed to enhance effective consumer protection mechanism, appropriate supervision, enforcement capacity, and overall intelligence on financial stability, financial inclusion, and market conduct. Looking ahead, one of the AI for good projects we'd like to design would be a digitally enabled nano-saving solution as an impactful financial inclusion instrument. And then I'll hand this over to Peter. Yes.
Thank you very much, Najwa. Over to Peter. I hope this will work because Peter is in a remote location right now. Peter, can you hear us?
Hi, Jeremy. Yes, I can hear you.
Great. Over to you, Peter, for a presentation from Tanzania.
Thank you so much, Jeremy. So I'm sharing highlights from an experiment that we conducted in Tanzania in collaboration with our partner called XSAI and the Zanzibar Commission for Tourism. And in fact, we used AI techniques to understand the challenges faced by the tourism sector in Tanzania. And our problem is that the tourism industry in Zanzibar accounts for approximately 27% of GDP, but in fact, it is faced by different challenges. That includes undercapacitated institutions in the sector, lack of professional competence, and crumbling infrastructure. However, for the purposes of this experiment, we concentrated our efforts in identifying the issue of lower returning rate of tourists after first visit to the islands. Some research indicated that, with the exception of Kenya, the majority of 15 source markets for Zanzibar were first-time visitors to the islands, with repeater visitors accounting for only 14% of the total. So we therefore indulged in web scraping, the TripAdvisor website, to find out what tourists are saying and how they rate various tourist attractions in the island. So what did we exactly do? Of course, we divided Zanzibar into 4 sections and reviewed all the top attractions in each. The review considered forums and ratings of the attractions. We used natural language processing techniques. We did use Python to scrape data. And then, of course, for text analysis, we used IMB natural processing tool to conduct sentiment analysis on the text. The benefit of this process is that it saved time, but also it provided easy access to data and also reduced the effort required to collect data, and it was relatively accurate. So what have we seen so far? We were able to collect information from selected attractions and work with it efficiently, of course, thanks to this methodology. And we were able to identify attractions available in Zanzibar City and by attraction category. So for example, museums or historical sites, but also the attractions and categories with the highest number of ratings and average scores, but also the demographics of visitors that visited each city in the 4 cities that we divided. And then, of course, we looked at the timing as to when exactly each attraction and each category received more visitors. So in summary, what we found out is that all the texts had an overall positivity of 0.42%, the scale being -1 to 1, and that is referring to forum data. And there was sentiment variation within each parameters that we did assessment, that is health, transport, etc. But also the attractions, most of the attractions received more ratings from couples that visited than solo visitors. And also the key attractions ratings, there was certain fluctuations depending on events or pronouncements. So for example, you'll see that there were more or less visits during elections, for example. But also we also visited. I mean, we saw variations in other areas as well. So couples, for example, the last finding is that couples made up 36.4% of visitors, while business travelers made up of 1.39%. So these are some of the highlights of some of the findings we see. But in this space, in Tanzania, we see a lot of opportunities that are presented in the AI space. So for example, some of the opportunities are the support to the policy environment, but also technical and financial assistance to various businesses that are doing AI in the innovation ecosystem in Tanzania, but also encouraging collaboration and partnerships among AI in AI circles in Tanzania and beyond, but also assist with the establishing of high-tech infrastructure such as AI labs to fuel AI development in academia. And lastly, collaboration with Tanzanian institutions to develop research and study causes. So those are some of the opportunities that we see. So I will stop here, thanks, and please join us as we work towards democratizing the use of AI tools for social goods. So that's all from me. Back to you, Jeremy.
Great, thank you very much, Peter. Moving on, we have a presentation from Sudan. I am not sure whether Wigdan has been able to make it because apparently she's feeling sick today. Is Wigdan on the call? If not, can I hand it over to Ali?
Yes. Hello, everyone. Thank you so much. Thank you, Jeremy Boy. I'm not the most prepared, but I will do my best to go over it. So in Sudan, we have gone through a few kind of AI products throughout last few years. And mainly, we kind of divide these products in operationalizing UNDP's work internally and how we kind of look at exploring outside and horizon scanning outside. So one of the major things that I think we've worked on with also QCRI, or there was been collaboration, was the Sudan Horizon Scanner, which is software which automates horizon scanning. And it's kind of like a function of a brain where you kind of collect a lot of information and analyzes it to kind of see what is going outside and understand some of that complexity when situations of the different things that are happening within our context, especially within this kind of transitional period. This kind of platform has enabled us to understand a lot about what's going on in an early warning kind of situation. Another one is a floating structure, which is automated UNDP's data strategy with internally, understanding, because there is a lot of influx of data coming to UNDP. And so trying to structure this kind of data, it needed an element of how we can flexibly do this work through an automated structure, and this is what it's called the floating structure. There is no key. It's more like a horizontal kind of structure that brings in all of these various data into an AI protocol, so it can drive insights from this data and provide you with knowledge. And this is to help UNDP internally on how they can work. Our origami structure kind of links to the floating structure in a sense that it filters about all of these different components and various data that we have and optimizes on human resources. So one of this is to train the AI on the accumulated data to bring in various the skill setting that people are needed and link them to some of the tasks that needs to be done, especially within the organization's goals and some of the things that are developed. And to suggest also how these skills and various matchmaking abilities into the projects and interventions that are out there. Next slide, please. So another kind of element was about a scenario building game, which is it uses the future thinking methodology. And it's about kind of looking at scanning the horizon for the future, especially in elections in Sudan, since it's with the complexity of the situation, trying to look at areas of civic education and understanding some of the voter behaviors and looking at how that can produce something that can help with the democratic transition in the country. Another one is the Health Pulse, which is a community-based health surveillance system, which analyzes health data and kind of gives us understanding with links with what our portfolio here, the health portfolio, is doing, and trying to look at some of the interventions that we're looking at. The CRD is the Crisis Risk Dashboard, which is a global data mandate that we're doing, but what we are trying to do is localize it in a setting where it kind of becomes like an early warning system through predictive modeling and including dynamic models projections. So this way it kind of gives us a general understanding of some of the issues, especially when it comes to conflict within the various areas in Sudan, and how this kind of makes our interventions faster and rapid when it comes to in these crisis settings. So the last one is the one that I've been working with QCRI for. It was an experiment to expand the capacity of looking at how we can link artificial intelligence to some of the propaganda and AI fake news. So Perslav, a fellow in QCRI, has given us access to some of their AI systems, and we kind of utilize them in an experimentational model to understand some of the fake news that came out of some of the topics that we have found, especially in the COVID-19, and some of them during hate speech issues, especially with the peace agreement in Sudan. And this gave us a lot of insights about how the AI works, but also about some of the fake news and propaganda and how malinformation, disinformation can really affect some of the behaviors of people. So we wanted to look at how can we access some of the knowledge that we have with behavioral science and trying to link them to artificial intelligence. And this is something that we wanted to discuss also with Perslav and see how we can link these various things that we've learned so far from the experimentation of these various platforms that QCRI has developed. And if we can enhance them using some of the nudging methods and looking at a way to counter the fake news, propaganda messaging, and even violent extremism thoughts and messages that are coming up in social media. So where are we at this kind of stages in these projects? We are, for instance, in the AI for fake news, looking at how to enhance it through BI. We're just in the conceptualization methodology kind of level, looking at, because there was interest in that level. So we wanted to see how we can develop that logic, algorithm development, and see if it can function. So it's kind of like an experimentation on models yet. The Sudan Horizon Scanner is in software and testing development. So there is, what the areas of support that is needed is more in the cloud database management, help with some of the tasks that are coming up of execution. The floating structure is also in software development. Origami structure, the same. The Sudan scenario building game is still on the conceptualization, so it's a high-level design and it requires software development and looking at some of the expertise in future thinking and linking them together and seeing how this could be done. There's also the health pulse, which is in the methodology level. So the conceptualization is out, but now it needs to be kind of linked to that data management as well and seeing how this could be executed. The crisis risk dashboard and the prediction kind of conflict prediction element and the early warning is in the logic and algorithm development. We've kind of finalized the methodology, and now we are in the level of how do we kind of look at the algorithmic level of it. And
thank you, Ali. This is sorry. I'll cut you off here just for the sake of time. Sorry, but thank you very much for stepping in for the presentation here. I think we got the gist of it, and it's all very interesting. Thank you very much. And sorry to have to interrupt like this. Any last words, or do we move on? Okay, moving on to Uruguay. We will hear from Paula, who will talk about tracking what matters in real time, misinformation and gender violence.
Thank you very much, Jeremy. Hello, everyone. It is great to be here. Thank you very much for the invitation. My name is Paula, and together with Francisco and Alvaro, we integrate the Accelerator Lab in Uruguay. Firstly, I would like to present you just a few data about our country for you to have the big picture. Being a small country between Argentina and Brazil, Uruguay is among the countries with highest fiber optic internet penetration, with highest download speeds in the region. Uruguay leads the region in the global ranking of the government AI Readiness Index, and is part of Digital Nations, a group of the 9 most digital advanced countries in the world. More than 400 companies are choosing Uruguay as their base to serve the rest of the region. And we have Plan Ceibal, that it's a plan that gives free laptops to all public school students. So Uruguay is a great digital country that allows us to experiment new technologies. Next slide, please. We are working right now, next slide, please. We are working right now on how to use social media data and data analysis to generate evidence for public policy on urgent social issues. I will share with you 2 experiences: a vaccine acceptance tracker that we developed last year, and the gender violence tracker that we are developing right now. Next slide, please. As there was a lot of misinformation regarding COVID-19 vaccines, we developed the vaccine acceptance tracker to understand what was driving the acceptance or rejection of the vaccines. Therefore, this tracker that we developed uses social media listening tools to identify Twitter conversations advocating for or against the COVID-19 vaccines in Uruguay. Next slide. It has 2 parts, a monitor and a quantitative graph, as you can see, where there's a daily score and there's a dynamic dashboard with the net vaccines acceptance score over the time. And there's also a qualitative analysis where basically analysts, people, generate a daily report with strategic inputs on what is driving the acceptance or not of the vaccines. Next slide, please. So this experience allows us to validate these kind of tools, these technologies, and the usability of it for many other opportunities like this one, gender-based violence, climate change, future of work. And that is why we are developing right now another tool to understand what is driving gender violence on Twitter. Next slide, please. So as a strategy for generating evidence for public policy, we are developing a real-time public dashboard that provides information on gender-based violence online. We will publish this in May, and we can share with you, of course. And the dashboard will feed data from Twitter, use artificial intelligence. It will be a specific algorithm for Uruguay that will provide insights through interactive information and visualizations. Next slide, please. So as you can see, there are a lot of opportunities. We are testing many of these tools in Uruguay because it's a great digital country for exploring, experimenting, innovating, and scaling. Thank you very much.
Thank you, Paula. Over to you, Ingmar.
Great, thanks. Yeah, so let me share this. So I'll hand over to Preslav in a second, whose name we had already heard mentioned before. Let me just, right, and
okay, so information, propaganda, and media bias by making users aware of what they are thinking. and thus promoting media literacy and critical thinking. And we have been developing a number of tools, and here I'm going to just show you some of them. So this is the output of a system that unfortunately don't have time for me to show you. But if you give it the URL, it's going to tell you things about this URL. It's going to tell you how propagandistic it is. This article is going to tell you how biased it is, left, right, and so on. It's going also to tell you something about the source of this article and its general bias and general factuality of reporting. And then it's also going to tell you other things, including what specific propaganda techniques have been used in the text. So, for example, here we have maybe exaggeration. Here we have some kind of labeling, name calling, and stuff like that. Yeah, you can paste the free text, or you can kind of paste the URL, and there's some further analysis that has been done there. Other things we have been working on recently is we have been working on analyzing memes, because they are much more influential, and the propaganda and how it's being spread through memes. So, for example, here on the left, it's in the context of coronavirus, COVID-19. So there are propaganda techniques like appeal to fear, black and white fallacies, so you're either, you know, sheep or a wolf. And he's like whataboutism, accusing people of hypocrisy. Yeah, we have been like working on automatically analyzing this using both the image and the text content. We have been also working in COVID-19 disinformation detector that works in 4 languages: Arabic, English, Bulgarian, and Dutch. And we are adding several other languages. And given a tweet, it's going to tell you whether it contains verifiable factual claim. Is it likely to be false? Is it does it look like it's general public interest? Is it harmful? And is it worth fact checking? And then if it's worth fact checking, actually, you know, the specific reasons why this is of interest to policymakers and government entities, and why it's actually harmful to society. It can be for a number of reasons. It can be because it spreads hate speech or panic or rumors and so on and so forth. We have been also working with UNDP on this is under development, but we're kind of progressing to analyze the language of diplomacy and to detect things like the sense of direction, sense of urgency, great affection, and so on and so forth in different teams, and kind of to automatically annotate and understand text. And finally, we have APIs, so these things are available, and you know, our you have already heard that people in Sudan have been using them.
Great, thanks a lot for running through this. I'll hand over to my colleague Hamdi.
Hello, everybody, and welcome to this presentation. I'll talk about Arabic language technologies at QCRI. I'll talk about Farasa Arabic NLP components and Arabic social media analytics platform Asad, and my colleague Ahmed will talk about other components. So this is a brief background about Arabic challenges. Arabic has a rich and complex morphology, both derivational and inflectional. So one word in Arabic can be written in or translated into 5 or 6 words in English. For example, this word. And Arabic is normally written without diacritics. Imagine that you write English and you remove all the short vowels. So a word, unspecified word like CR can be car or care or cure or core, whatever. And we have other challenges, like we don't have capitalization in Arabic. We have a lot of spelling and grammar mistakes, etc. So this is the complexity of Arabic. The sentence written in red can be the approximate complexity to Arabic language compared to the English one, which is written in green here. We built Farasa NLP tools to handle different components. For example, here this is screenshots from the segmentation, part-of-speech tagging, and also diacritization. And as we can see from the first screen, the complex word is segmented into prefixes and suffixes and the core word of the word, and also the part-of-speech tagger gives the morphological information about the word, something like this is the conjunction followed by a future particle followed by verb, etc. And the diacritization component restores the missing vowels. We have also component for spell checker and named entry recognition to identify the person names, locations, and organizations. Another component is for detecting the lemma for each word in the sentence, and for generating that three parts for each sentence. Another engine, which is Arabic social media analytics platform, Asad. First, we detect harmful and unwanted content, such as offensive language, hate speech, spam, and adult contents. And we give some information about the text, such as the dialect of the text, the sentiment, emotion, the categories of the text. And also, we identify some information about the user, such as the gender of the user, the location, and the country of origin of the user. Asset can be tested using the online interface. Here, a screenshot from the engine, such that the user can select any functionality and write a text. Here, for example, the dialect component say that this text is written written in the Qatari dialect with this percentage, or Bahraini dialect, etc. So this is the random samples from different components. And Sacro components are integrated into Sacro social media monitoring platform. We have another component to detect the stances of users according to their stances with respect to a topic. And we classify users according to their opinions. We integrate all these components together such that if we have a large number of tweets, we can detect the general sentiment or the emotion or offensiveness over time, and also visualize the data using polarization score, for example, and the most common hashtags and users for each cluster. Thank you.
Next, we have Ahmed Saplari.
Yes, thank you. Thank you, Mark. Okay, so yeah, so this is like some additional tools that pre-process or work on mainly on Arabic. So as we are providing a whole ecosystem for pre-processing Arabic. So this is Natiq Arabic to speech that generates like from a given text. It provides like sound. So such technology could be used for many applications, mainly for assistive different types of assistive technologies, such as book readers, such as like screen readers. I mean, maybe to elevate, I mean, the burden from users to manipulate like a computer and so forth. So the system will issue voice notifications automatically. So far we have have trained different systems and deployed them that are available from the URL on top of the screen. So they are like a neutral male voice, and another voice which is like expressive, that is more geared toward education. Another system is Arabic CATS for speech recognition. So this is the other way around. So to detect for someone who speaks, and then you can generate sound from it. So okay. So and the last one is machine translation. So we have Shaheen system that translates Arabic into English and vice versa. Supports like different dialects and different customized to different domains, such as medical translation. We have celebrated a couple of months ago, translating over like 2 billion words through our systems. Thank you.
Right. Yeah. Thanks, everybody. Thanks for staying more or less on time. So last up in this block we have Reham Al-Tamimi.
Hello, everyone. Today I'm going to present our work on gender gap in science, technology, innovation, and mathematics, engineering and mathematics, and monitoring the Leaky pipeline. To give you some background of the research, so reducing the gender gap in STEM is important to achieve the Sustainable Development Goals, including goal number 5 on gender equality. According to the UN, women are still excluded from participating fully, despite the efforts that have been made to inspire women to study and work in STEM. The underrepresentation of women in STEM fields can be explained by several theories, including the Leaky pipeline metaphor. According to this metaphor, women are more likely than men to achieve STEM fields at multiple time points, from the beginning of college through academic tenure.
So the main objective of our research is to use online advertisement data to track gender gap in interest in STEM fields in the USA for different age groups. This is to find out if online data can mirror the leaky Pablo metaphor. So this is how advertisement data look like. So as Ingmar shows, advertisement on Facebook Ads Manager can get an estimate of the audience size. And these audience sizes can be filtered by different criteria such as location, age, gender, as well as interest and other platforms. For the purpose of our research, we have collected data covering different USA metropolitan areas, different age groups, different genders, and interests related to science, as technology, engineering, and mathematics, as well as non-STEM interests. We call them placebo. We calculated the gender gap indices by looking at female to male ratios filtered by interest in STEM, divided by female to male ratios of the number of users in each platform. The GGI takes values greater than 0, while lower values indicating higher gender gap and suggesting women at disadvantage. For interest in STEM and interest in placebo, we compare the GGI for different age groups. This is to find out if women comparing to men are losing interest in STEM as they get older. Thank you.
Well, thank you very much, Liam. So now I will hand back to you, Jamie.
Thanks, Ingmar. And we will have to speed it up even more because we're already at time. And we have our last pool of presentations here on remote sensing and the environment. We have 4 UNDP presentations and 3 QCRI ones. Jumping straight into it, we will hear from Yomna in Egypt on resilient food systems in the Nile Delta. Yomna, over to you.
Thank you so much, Jeremy. Today, I'll be sharing more high-level framework on how we approach our challenge from a system perspective and the opportunities we see for big data and artificial intelligence to strengthen that portfolio approach. So I'm not focusing on one example. We worked on climate resilience since Egypt is disproportionately burdened with climate crisis, and specifically the low-lying deltas of the Nile River is one of the world's 3 most vulnerable hotspots to sea level rise, extreme weather conditions, and other factors. And in the Nile Delta, agriculture has always been the main economic activities, and it's the one getting the strongest hit by climate change. It affects people, livelihood, and risk of food security. So we started learning on agriculture. Next slide, please. So we started learning on agriculture resilience as a gateway to socioeconomic resilience of local communities in those areas affected by climate change. And very quickly through exploration and mapping activities, we realized that to safeguard agriculture activities, we must build a comprehensive portfolio on resilience agri-food system as a whole. So take more a system approach or a comprehensive look on into that system. Next slide, please. So basically, looking at how we guide production, agriculture production, to shift to more climate resilient crops, but also learn if the market is ready for that kind of uptake, and eventually how the consumer can change their eating habits or behavior, so consumption would also join this transformation. And we tested our hypotheses at, next slide please, Jeremy, thank you. And we tested our hypotheses mainly using small data first, but we also, through doing that, we found opportunities for big data and AI to learn and transform at scale. And we attempted to do some of them, but due to some barriers, we didn't. This is where we want to go with data, so we're still overcoming some of those barriers. So for example, we approach guiding production by understanding farmers' behavior, their decision-making mechanism, and also leveraging on the know-how from experts and also establish solutions like, for example, contract farming. And although we found multiple venues for incremental improvements, but we also saw how we need a stronger evidence-based agriculture extension services that doesn't only depend on a single farm situation, but rather a nationwide planning, because eventually this big scale planning interact with the supply and demand, the market dynamics, and the economic viability of the agriculture output. And here we saw how the strong value to work with satellite imagery and AI for crop identification and crop planning for faster and working at scale to strengthen this guiding process. But I think that the main barrier for us was the capacity and capability for machine learning at that scale. And also on the other side, we used the power of social media communities to start a conversation with women to identify the best nudges for behavior change. It was in a closed women group, a very safe space where they spoke up freely and we got to learn a lot. But we initially wanted to use social listening tools that can help us reach a bigger audience and more representative analysis, but also due to language barrier and most of the users are on Facebook and we couldn't find a lot of open access data beyond Twitter and other more open platforms. So we started with more qualitative conversations, but we also can see how AI can help us apply some of those behavior nudges that we identify. Finally, for the market update, we experimented with climate resilient product innovation, which was faced by multiple question marks on supply chain, capacity, and size of demand. And here we know that integrated AI solutions can be of great value to predict and answer a lot of those questions in a timely manner. So despite that, all those barriers, what we are aiming, or what we're trying to say is not only that we believe in AI solutions for social good, but also integrated AI solution and how they can also help with system transformation and a portfolio approach. Thank you, and over to you, Jeremy.
Thank you very much, Yamna. Speeding along, we will move to Zimbabwe with Gift, who will talk about informal data sets for building resilience in Zimbabwe.
Thanks a lot, Jeremy. Also, I'm going to try to be as fast as I can. My name is Gift Ntuli, and I'm representing Zimbabwe. In Zimbabwe, I think our case is pretty straightforward. The challenge is that we're a highly informal economy, with some experts saying up to 95% of the working population is informally employed, either in their first job or their second job that they tend to call their side hustle. At the same time, our economy really relies on agriculture, with that agricultural sector being the biggest employer and also major source of livelihoods for most people. So our challenge then is how can policymakers understand what's happening within agricultural supply chains in order to combat the effects of climate change, and also COVID has happened in the last 3 years. And really the problem is that agriculture becomes a black box where, because of informality, people don't want to report their true figures. So what you get is the input, the farmers, and the output, the consumers. So our two thematic areas is shown on the next slide. We have one where we're looking at using informal data sets to gain knowledge products for policymaking. And our key challenge question here is that, is it possible for us to treat the agricultural system as a living organism and then do different forms of remote sensing to understand the to gather information that's being transferred from one player to the other player along different agricultural value chains, and then analyze that information to derive policy insights. And then the second one is to do with early detection of livestock diseases. As you can see on the screen, every year in Zimbabwe, we lose millions of dollars to what we tend to call the general disease, but this is a collective, a name given to collective diseases that usually happen during the rainy season in Zimbabwe. So looking at these two, if we go to the next slide, I will speak first about the data for policy insights, where 2 years ago, ACLEB Zimbabwe, working with the Chief Digital Office, we did, next slide, please. We did a technology demonstration where we're trying to prove that it's possible to gather informal data sets and turn them into actionable insights for policy insights. So we worked with a company based out of Silicon Valley called Frame-Massive, and we managed to acquire more than 250,000 data points for different crops, and again, trying to understand what's the price of these crops as they're moving hands between people, and what's the volume of the crop as we're moving from market to market in Zimbabwe. And I'm going to share the link to the findings, but in summary, we did get a lot of information regarding gender disparities in markets, impact of fiscal policies on markets, COVID, climate, and so forth. And as a result, this work led to a bigger project called the Safe Markets in Zimbabwe. And this is what I have displayed here, where now the government, working with the UNDP, they've set what we're calling an agri-tech data center within the Ministry of Agriculture. And we have two ways of collecting data around these supply chain nodes. So the first one, we're training agricultural extension officers to collect data. We've trained more than 30 now. We've also mapped our end users, the policymakers, private sector, and our everyday consumers. But where we see opportunity to work with QCRI is to do with collective intelligence. Because like I said, since the economy is highly informal, people don't want to report their true prices and volumes of produce. So we're saying is it possible to scrap information, whether on social media or different WhatsApp groups, to try and really understand the true information that's being exchanged between different players as we move across the value chains, and then use that to inform our policymakers. Going on to the next slide, with looking at syndromic monitoring of livestock diseases, I put some alien faces because this is really frontier work for us. So we've done some mapping and we've set out a technical working group that comprises of different players. And within this working group, we're saying, is it possible to use AI in different sensors to first do passive monitoring and understand more than 500 deep tanks that have been funded by UNDP to set up sensors and gather knowledge, insights on symptoms for diseases. But looking on the other side, active monitoring, again, we see an opportunity to work with QCRI here, trying to go through different channels of communication that are used, whether formal or informally, by different farmers who own small groups of cattle, and then using that information again to feed into this AI-based data processing, and then from those insights, then allow the Ministry of Agriculture to see outbreaks before they happen and save, again, I'll say tens of millions of dollars worth of livestock every year. Thank you.
Thank you very much, Gift. Moving along to Kazakhstan. Valeria, are you on the call?
Yes, I'm here. Jeremy, thank you very much. And let me introduce the City Experiment Fund project, which is implemented by our Accelerator Lab team. I'm having just one slide, so no need to switch. The main goal of the project is to combat the problem of air pollution in Almaty, which is one of the most polluted cities in Kazakhstan, with over 2 million inhabitants. The average annual fine particles concentration in the city exceeds the WHO limits by 5 times in winter period. Medical studies show a high prevalence of allergies, asthma, and breathing problems, and the situation even worsens during the pandemic. Overall, air pollution in the city leads to increased hospitalization and high expenditures for healthcare. The high levels of air pollution are due to intensive burning of coal in power plants, use of coal for home heating, high emission of traffic, and poor urban planning. So to achieve a system-wide effect, we examined weak signals and hidden barriers, which were lack of reliable air quality data, which leads to misinformation and inability to implement evidence-based policies, and lack of trust between the government and the citizens. So one of the core elements of the project is data innovation, which aims to develop an effective tool for air quality monitoring and awareness raising. To this end, we are partnering to different local and international organizations to combine different sources of data, such as on-site air quality sensors, satellite data, traffic data, and visualize them on a single platform, which is called airvision.com. I will share the link with you in the chat. Some data is already there, such as the air quality index, fine particles, nitrogen dioxide, and carbon monoxide concentration. There is also a function to report environmental violations and suggest ideas for green projects, and this could be done by every citizen. By the end of this year, we plan to finish analyzing the historical data, develop gamification and ranking to appeal to more users, integrate satellite air quality data, and conduct a full analysis of the traffic emissions data. So we are also working closely with the city government to improve citizen participation and facilitate environmental activities through the platform. That's it from my side. Thank you.
Great. Thank you very much, Valeria. Last presentation from Accelerator Labs. Over to you, Lillian from Lebanon.
Hey guys, how's everyone? So I'm going to be quick. Jeremy, when I just say slide, we can just jump through. Basically, in Lebanon, just brief context, we're 4.8 million people, but we've been going through a spiral of crises since 2019, the last of which is a deep crisis in energy security. We basically get 1 hour of electricity from government every day. If we're lucky, the others are majorly generators, or most recently solar panels. So just so we direct the conversation, our energy team is quite strong and we kind of know where we want to go, but the issue is what and how. So so basically what we try to do is before we've framed the problem as this energy security problem, obviously that has a cascade of impacts on other vulnerabilities across the board. What we did in November post-COP 2021 was a 1-week kind of experiment to test where people are in Lebanon around the solar energy journey. So what you're seeing is a basic marketing performance funnel that used Facebook Messenger, email, and Facebook ads to kind of identify 4 archetypes of people. If you go forward, Jeremy. We kind of built the archetypes around 4 pain points that we've noticed people have. The complete unawareness of this as a solution, the awareness but confusion, having no physical space or communal challenges in terms of deciding on solar energy for communal spaces, and at the point of actual purchase and the whole hazard that has happened with a market completely going into solar energy without being prepared. Next slide. So basically with microspend 1 week, and even though this is a very small data pool, we were able to gather that actually checking if your house is physically viable for solar panel installation got a lot of traction. And while we had only 400 downloads for our instructional material, we still got a lot of traction in this one particular area, which made us kind of look into it further through next slide. Looking at the regional resonance of these, like where, in which regions are people more likely to resonate with this particular topic, and what is particularly challenging. So besides budget, which we already know is going to be a drawback for people, it was majorly no space to install, and this is a communal space and I cannot make that decision. Which brought us into where we need your support or kind of seek a generative conversational space with data analysts. On next slide. Kind of looked at what other solution owners in the grassroots or academic field are looking into. Some people are looking into solar rooftops as a potential solution, but obviously, is this really about rooftops? Next slide. Given that this becomes a real individual solution, we as UNDP want to move into what can be a decentralized, more sustainable solution. Next slide. So what does the housing ecosystem say? In terms of looking at alternative data points, we want to look at maybe something like where apartments get listed, which is OLX. OLX is a big website for everyone wanting to look for apartments or living conditions in Lebanon. I think there's a lot there in terms of looking at where people are, especially that the market now is very much skewed for people who own dollars and people who own Lebanese lira. And what does that mean for their energy security? Next slide. We also want to look into nighttime data or luminosity. We are seeing Open Maps Lebanon, which is a partner or grassroots solution partner in terms of data, that has been tapping into this and looking at luminosity as a way to look into how people are experiencing crisis. And we expect that now this is actually much more interesting data because basically Lebanon has plunged into darkness. Next slide. Next slide. So we see Lebanon as a premonition state for any kind of foresight work in terms of energy scarcity. We've been in the situation for almost 30 years now with getting little to no electricity, and now we're actually at the forefront of it. So we look at this as a behavioral tipping point where the pain of changing into solar energy sources has become bigger than the actual gain from it. People are confused and they're lost, but it's actually a big opportunity in terms of crisis. So we really want to work on this in terms of alternative data modes. Next slide.
I'm sorry, Lillian, I might have to cut you off now. Just
Okay,
so
sure.
that we can give our QCRI colleagues some time before the top of the hour. Sorry,
Okay, thank you.
Thank you. Ingmar, over to you.
Yeah, great, thanks. So we'll have, so on the sort of satellite or image side, we'll have further present next.
Hello, I'm gonna quickly present a few use cases where we analyze images typically posted on social media during disasters to extract actionable information that can enable better humanitarian response. One of the use cases is rapid damage assessment, which is one of the core situational awareness tasks. To achieve this task, we developed a system pipeline that can ingest live Twitter data, filter out irrelevant and redundant content, and then assess the overall severity of damage seen in the images into 3 categories, like severe damage, mild damage, and no damage. We deployed this system during many disasters in the past, including Hurricane Dorian, where the dashboard looked something like this. The end users could play with the different filters and see the reports much faster than if they were to do this manually. And we made sure that this system is modular and flexible enough so that we can apply it for different use cases where we can simply change damage assessment model with, let's say, landslide detection model, which needs to be built, of course, and which is what we did. Now we can use the system for detecting landslide reports posted on social media in real time. And we have been doing this for like more than 2 years now in collaboration with European Mediterranean Seismological Center and British Geological Survey, where we provided them with the real-time monitoring of landslide reports detected on social media. Similarly, we also looked into another use case where we kind of analyze damaged heritage sites. But to scale things up and to go beyond like overall damage assessment or landslide detection, we built a large-scale data set where with 1 million images labeled across 43 different incidents categories and 49 different place categories. And thanks to this data set, we can now afford training robust models that can understand various types of disasters in various scene contexts. And actually, we can use this model to create a real-time disaster monitoring system, a map that can be used as a first alert by humanitarian organizations. I'm gonna finish.
Oh, okay, thanks. Even with some time to spare. Next up, we'll have my colleague Rizwan. Best to use.
Hello, everyone. So I will quickly go through our work on integrating remote sensing and social sensing for flood mapping. So in this work, we are having basically 2 different pipelines in which we integrate different heterogeneous sources. Namely, one is like remote sensing, in which we used synthetic aperture radar imagery, and also we have the pipeline for optical imagery. So our deep learning models can process both type of imageries and can generate a flood segmentation masks. So now these flood segmentation for masks can be obtained for different areas, but they will not be providing us with the different information which give us some context about the flood. They can give us the extent from the aspect of the city area or the big areas, but they will not tell us how much damage has been caused and what situational reports can be generated. For that purpose, we integrated another heterogeneous source, which is social media. As my colleague further mentioned, that social media content, especially the Twitter, can be processed, and for that we use different deep learning models which can tell us, okay, this tweet is related to damage. It is giving us some information, what disaster type it can. These models can predict the disaster types, and for these models can predict different disasters, but we only picked the flood disaster type, and we then combine these 2 outcomes of the models, flood segmentation maps and the information from the tweets coming from the different models, and we integrated them to generate a complete flood map, which will give us more information. So these informations these informations can be in terms of humanitarian reports or the flood segmentation maps. So when we have remote sensing and the social sensing combined, we will have different type of signals. These signals can be confirmatory signals where we have the confirmation that social media is telling us there is a flood, and the satellite imagery is also confirming that there is a flood in a specific area. Or we can have some information like where we have satellite imagery telling us there is some flooding, but social media tweets are not exactly in that location. They are from different vicinity, but closer to that flooded area, and they can confirm some complementary signals. And then we have some novel signals in which we have some tweets or social media contents coming from a different region, not exactly located where the flooding is occurred, but they can give us like a different context where the flooding is occurring. And basically, yeah, that's it. This gives us like, we can combine these sources. And yeah, okay, thank you.
Thanks, Rishwan. And last but not least, we'll have my colleague Umayya.
Hi everyone, I would be presenting about a very interesting and challenging problem about geolocating social media data. So on Twitter, there's so much noise. When you're sifting through different tweets, you don't know where they're coming from. So some of the attributes that Twitter provides us is just tweet text itself, and there could be location cues mentioned in the tweet text. For example, in this case, you can see Associated Press tweeting about the Algerian president and his evacuation from Germany because of COVID. You can have cues in user description as well. For example, in my user description, I have written research assistant at QCRI, working in Qatar. So in this case, a news platform has mentioned California and United States. Sometimes Twitter gives you ability to tag where you exactly are, and it comes with a place tag as well. For example, in this case, this user has mentioned that she is posting from New Jersey. And in other cases, you can have like some user location mentioned as well, in which you can just do a free form text as well, just mention like Earth or whatever. In this case, the person has mentioned USA. So the idea is to gather all these different location cues and try to identify specifically where that social media information is coming from. And for different use cases, you can have different kind of priorities. So we have like a location resolver, so to speak, in which you can set different priorities. For example, you're only looking for people where they are tweeting from, for maybe user location is referencing, useful for that case. We have named entity recognizers as well in different languages, which are able to sift through specific tweets in different languages. And we have Nominatim as well, locally deployed. This is provided by OpenStreetMap. If you go online and try to look for some query term, for example, if you search for Doha, Qatar, it gives you some place object that allows you to kind of tag them as well. And we make use of some sort of smart caching mechanism as well, so that we can quickly detect the location of a tweet. So what are the applications of this geo inference? So some of the applications that we have used more recently is for crisis location detection. For example, when a person is tweeting where a flood is happening, you can see there are location cues in text. In other cases, there could be location tweets in, for example, user location. And in other cases, you can have when Hurricane Ida happened in Louisiana. And you can also use it for targeted advertising to target specific population. Thank you.
Great. Yeah, I think from our side, that's everything so far. So I think the audience can be lucky. They only paid for 90 minutes, but they got 33 minutes of bonus content, so to speak. So I'll hand back to Jennifer, maybe
bonus content. Yeah, this was amazing. Thank you, everyone from QCRI and the Accelerator Labs. My head is, I don't know, swimming, possibly going to burst in a minute. But yeah, we were intending to do kind of side sessions between QCRI and UNDP. But I think it's great that we had everybody have an opportunity to present. So this is kind of the teaser a bit, what we've done today, and the plan is to reconvene in Doha in mid-June, bringing together data scientists from a variety of sectors, along with our hosts at QCRI, to go through in more detail the data challenges, or the development challenges that our colleagues have described. If you're interested in participating, please be in touch with Ingmar, Jeremy, or myself. I think with that, I'm going to wrap us up. So I want to say thanks, Ingmar, for orchestrating this, and gathering your colleagues at QCRI to share their expertise. Jeremy, thank you to you and the Accelerator Labs for bringing the challenges that they've presented today, but also really kind of inspiring work. Kind of the diversity of ways that they're addressing challenges has been great. So you will hear more from us in the coming weeks as we head up to the event in mid-June in Doha. And with that, I will just say thanks again, and see you next time.
Thanks. Bye, everybody.
Thank you, everyone.